Hey everyone, welcome back to the College Algebra playlist. We finally reached the end of Chapter 2 in the textbook, which is all about solving equations and inequalities. Alright, so now we're ready to move on to Chapter 3, which is all about functions. Alright, functions are really interesting. In fact, this video is the one I've been most excited to make so far in this playlist. Alright, so without further ado, let's start talking about functions right now. Okay, here we go. Before we start talking about functions, we need to talk about something called relations. Alright? A relation is a set of ordered pairs. The set containing the first components of each ordered pair, the x-coordinates, is called the domain. And the set containing the second components of each ordered pair, the y-coordinates, is called the range. Alright? So here's an example of a relation. Alright, we can tell it's a set because of these fancy braces we're using. All right, so it's a set of ordered pairs. All right, and the first values, right, the first components of each ordered pair, these values in blue here, those values make up the domain. All right, and the red values make up the range. Okay. Every value in the domain is an input value or independent variable and is often labeled with the lowercase letter x. All right. And every value in the range is an output value, or dependent variable, and is often labeled with the lowercase letter y. Okay? So in our example from the previous screen, right, the domain is this set here, right? It's this set of x values in blue, all right? And the range is this set, the set of y values. Okay? So now let's talk about functions, all right? Functions are a special type of relation. A function is a special type of relation in which every possible input value corresponds to exactly one output value. All right? The input values make up the domain, and the output values make up the range. Okay? So in this example from the previous screen, right, this is an example of a function, okay? Because every input corresponds to exactly one output. All right? This example would not be a function. All right? Because of these threes here, right? 3 is associated with two different outputs, 7 and 9, all right? And that's not allowed in the function realm, all right? Let's visualize functions in a different way, and let's try to generalize this a bit, all right? This blob here, right? This is my input, okay? So this is the domain, and this blob over here, this is the output, or this is the range, all right? So we're mapping A to S and B to T and C to U, all right? Every input is associated with exactly one output, all right? So this relation is an example of a function, all right? And this example is a function as well, all right? A is associated with S, all right? And we map B to T, and we also map C to T, all right? So just because they have the same output doesn't ruin it, right? It doesn't make it a non-function, all right? Every element in the input is associated with exactly one output, all right? What we can't have is something that looks like this, all right? This relation is not a function, okay? We map A to S, all right, so it has one output, but here we're mapping B to two different outputs, T and U, all right? And that's not allowed in the function realm, okay? So this is not a function, okay? So the question I want to ask now is, how do we get from A to S? All right, how does this mapping occur? All right, A is being passed into F, the function F, and that function performs some sort of operation to get to S. All right, so let's write down a second definition for functions. All right, a function F is an operation that maps every element in the input set, the domain, to exactly one output element in another set. That's the range. All right? So here are some questions that are going to come up. All right? First of all, what do we mean by operation? All right? Also, how can we express functions mathematically? And also, how can we visualize functions? Let's talk about something called the function machine. All right? This is a classic sort of drawing that we use to visualize functions, okay? F right? The function f is this box, and it has an input chute and an output chute, and it has a crank that you turn, all right? So we take x, all right, which is also called the independent variable or the input, all right? We take x and we plug it into this function, all right? And then we turn the crank, right, to perform some sort of operation. And what comes out is y, all right? And y is known as the dependent variable or the output, all right? Let's talk about independent variables and dependent variables a little bit, all right? We can choose any value we want for x, all right? That's why it's called the independent variable, all right? So we can plug in any value we want for x, all right? The value of y depends on the value we choose for x, all right? That's why it's called the dependent variable, all right? So let's look at an analogy for functions, all right? Let's look at something in the real world that can represent this idea, all right? Here I have some various fruits and a blender, and I have some types of smoothies, all right? Look at this fruit here, all right? We can choose any fruit we want to make whatever smoothie we want, right? So that's the independent variable, aka the input, all right? So what we do is we take that input and we put it into the function, right? We put the fruit in the blender, and then we push the button, and the blender does its thing, right? It performs an operation on the fruit. And what comes out is the type of smoothie, all right? So that's the dependent variable, aka the output, all right? So the type of smoothie we get depends on what fruit we put into the blender, right? We put in strawberries, we get a strawberry smoothie. We put in mangoes, we get a mango smoothie. And we put in blueberries, we get a blueberry smoothie, all right? So this is a fun analogy I like to use to talk about functions. Here's another one, all right? I have a hand formation and an acoustic guitar and a chord, all right? The hand formation is the independent variable, all right? That's the input. And the guitar is like the function, okay? So we make a hand formation and we put it on the guitar, all right? And what comes out is a specific chord, okay? So we go from hand formation to the guitar to the chord type, all right? To a specific chord. So the type of chord we get depends on whatever hand formation we use, all right? Here's a challenge for the viewer, all right? See if you can come up with some other real-world analogies to talk about functions, all right? Let me know what you come up with and put it in the comments below, all right? Now let's talk about function notation, all right? The notation y equals f of x defines a function named f, all right? This is read as y is a function of x, okay? The letter x represents the independent variable, aka the input. We know this already, all right? The letter y represents the dependent variable, or the output. And the value of y depends on the value we choose for x, all right? So here are 3 examples of mathematical functions, all right? This function says to take what we're given, multiply it by 3, and subtract 5, all right? And this function named g says to take what we're given and square it and subtract 4. And this function h just says to take the input and take the square root, all right? So let's go back to the function machine, and let's talk about a specific choice of function f here. All right, f of x equals x squared, all right? So what we're going to do is we're going to plug in -2, all right? We'll take -2 and put it into this function machine, and we turn the crank, right? And when we do that, the function squares the input, all right? So -2 squared is -2 times -2, which is +4, all right? So now what we want to do is take this input and take this output and pair them together in this ordered pair here, all right? If we plug in a -1, right, we turn the crank, and what we get is +1, okay? So let's put those values together in an ordered pair, all right? Also, if we plug a 0 in here, right, we plug it in, and then we turn the crank, and what we get is 0 squared, which is 0, all right? So let's pair those values together, 0 and 0, okay? And when we plug this 1 in, right, we turn the crank, and what we get is 1 squared, which is 1, okay? So let's put those values together. And finally, when we plug a 2 into this function, right, we square 2, and we get 4, All right, so our last point is 2, 4. All right, let's visualize this function on the coordinate system. All right, so let's get rid of the function machine. All right, we want to move to the coordinate system now. Okay, so let's plot these points. All right, and let's draw a curve through the dots. All right, this function, f of x equals x squared, is represented by a parabola. All right, so whenever someone asks, what does the function look like? What they mean is, what does the curve look like when you plot a bunch of points? All right, we can plot as many points as we want, by the way, right? We can choose an infinite number of values for x, all right? And the corresponding value of y, right? We put those values together in an ordered pair, right? And that point will be on this parabola somewhere, all right? So next, let's talk about something called parent functions, all right? A parent function is the simplest, most basic form of a specific family of functions, serving as the starting point for transforming functions. All right, transforming functions is a future topic. All right, I'll make a video on that later in this playlist. All right, so a parent function represents the fundamental shape and behavior of a function before any horizontal or vertical shifts, stretches, compressions, or reflections are applied. All right, so those are all examples of transformations we can make on a function. Okay. So let's look at a short list of parent functions. All right, here's a well-known function, right? This is what we just looked at. This is f of x equals x squared. All right, the quadratic function looks like this, right? It's a parabola. Okay, we know this already. The cubic function, f of x equals x cubed, looks like this. All right, and the identity function, f of x equals x, looks like this, right? This is a straight line. All right, so what this function does is it takes your input and it just outputs the exact same thing. All right, so you put in a -2, you get out a -2. Put in a -1, you get out a -1, and so on and so forth. All right, so this is a line. Okay, and this is the constant function. All right, f of x equals c, where c is a constant. All right, in this case, c equals -2. All right, so what this function does is no matter what you put in for your input, it always just spits out c, right? It always spits out -2. Okay, so this is the line y equals -2. All right, this is what absolute value functions look like. All right, it has this V shape. All right, and there's the reciprocal function as well, which is defined by these two curves here. All right, also there's the reciprocal squared function, right, which looks like this, right? It's defined by these two curves. Then there's the square root function, right? You just take the square root of x and you get this swoosh thing. All right, and finally, there's the cube root function, which looks like this, right? It's this curve here. All right? So this is how we can visualize functions, right? We plot a bunch of points, and we draw a curve through those points, and we say this is what the function looks like. All right? That does it for this video. Thank you for watching, and like and subscribe.